Hi everyone, my name is Tashia Floyd, and today I'll be presenting on transcranial magnetic stimulation and how it alters neuroplasticity in depression. So I'll first describe neuroplasticity, which we talked about in this course. And it can be defined as the ability for the nervous system to adjust itself in response to injury, environmental changes, aging, and experience. Neuroplasticity is one of the key mechanisms during neurodevelopment and just everyday functioning of the nervous system. It can be described also as physical changes at the neuronal level, causing alterations of neuronal circuitry and neuronal firing. A few examples of plasticity in the brain are the Hebbian plasticity, which is more fine-tuning where connections between neurons are selectively strengthened in an organized fashion to sustain certain activity for long periods of time. And Hebbian plasticity can be summed up in the phrase, neurons that fire together, wire together. So representational maps are another example, and they represent the relationship between brain tissue and specific parts of the body. So sort of like the homunculus that we learned about. And these representations, they make it easier to understand how, for example, if a person loses sensation in a few of their fingers due to peripheral nerve damage, within weeks, those intact fingers will take over the cortical space originally represented by the damaged fingers, so a person won't lose the ability to use their hand. And finally, there's the critical period, which is usually related to children and language. So this period describes how learning a language is much easier in early childhood, yet after the critical period, it becomes a lot more difficult. And research has shown that this holds true for vision as well. So if a newborn has visual problems and an eye that isn't corrected by a certain age, their vision will ultimately be limited in that eye even into adulthood. So on the other hand, an adult who has always had normal vision and later in life damages an eye can regain those visual abilities in that eye no matter their age. So the critical period is basically important for gaining new abilities and being able to regain those abilities if necessary. So on to discussing depression, which is defined as prevalent and persistent low mood and lack of pleasure impeding on one's social, vocational, and mental functioning. And it's said to be one of the most common mental disorders by the National Institute of Mental Health. As of 2017, 7.1% of Americans have been diagnosed with depression, while 20% have been diagnosed worldwide. It also increases one's chances of being diagnosed with other diseases such as heart disease, and it increases one's chances of earlier mortality. So symptoms of depression include loss of interest in everyday activities, problems eating, sleeping, and concentrating, and issues with self-worth. And it's associated with plasticity dysfunction, which I'll be discussing more in later slides, and can be treated using antidepressant medications such as serotonin reuptake inhibitors, psychotherapy, as well as neurotherapies like transcranial magnetic stimulation or TMS, which I'll also be discussing more of. Depression in the brain mainly affects limbic regions such as the hippocampus, which is found in the temporal lobe. The hippocampus can be divided into the hippocampal proper and the dentate gyrus, and is involved in learning and memory, emotional behavior, spatial navigation, and regulating hypothalamic functions. So a lot of people assume that the hippocampus is mainly affected in individuals with Alzheimer's disease because of its huge role in memory, but it also has a huge role in regulating the hypothalamic pituitary adrenal axis, which is activated when we're stressed. And this makes it more susceptible to depression and the most studied region in depression as well. The prefrontal cortex is also a region in the limbic system affected by depression, and it's implicated, sorry about that, in more high-level critical skills such as emotion regulation, attention control, and goal-directed actions. It's divided into the medial prefrontal cortex and the dorsolateral prefrontal cortex. What's interesting about the two subregions of the prefrontal cortex is their opposing effects in depression. So while the ventromedial prefrontal cortex shows hypoactivity or less activation than usual, The dorsolateral prefrontal cortex displays hyperactivity or more activation than usual. Additionally, lesion studies have found worsening depression in individuals with damage to the ventromedial prefrontal cortex, but alleviated depression when individuals have damage to the dorsolateral prefrontal cortex. So that's just interesting how they have these opposing effects. So finally, we have the amygdala, which is usually considered the ultimate emotion center, but it's actually more involved in fear than any other emotion. So it's found in the temporal lobe as well, and is involved in emotion regulation, memory encoding, and plasticity during fear conditioning, meaning that neurons in the amygdala connect more when we're learning to be afraid of something. So the amygdala has remarkable impaired functional connectivity, mainly impairments in its connections to the regions of the prefrontal cortex, which is considered a biomarker of depression. So this slide, it just shows the various ways that depression impairs neuroplasticity in the regions we discussed. So, for example, in the hippocampus, depression alters long-term potentiation and prolongs long-term depression. And we talked about both of those in this course as well. In the prefrontal cortex, it reduces glutamate and GABAergic pathways. And in the amygdala, it actually enhances synaptic plasticity. So, on the positive side, transcranial magnetic stimulation is a non-invasive and painless technique that could actually reverse the negative effects depression has on neuroplasticity. So, TMS is the stimulation of brain regions using magnetic pulses. It has been effectively used in adults, children, and even pregnant women, which is a great alternative, especially for childhood depression, since studies have shown that antidepressant medication can actually negatively impact brain development. So it's really a good treatment for individuals who are resistant to antidepressants and is FDA approved as well as recommended by organizations such as the American Psychiatric Association. So a typical TMS session lasts only about 30 minutes to an hour, and it doesn't require any anesthesia. And the idea is that stimulating or inhibiting brain regions associated with depression can adjust neural circuits by modulating neurotransmitters and synaptic plasticity. So looking at the image, the machine can be placed over a specific area of the scalp, and this allows these brief electromagnetic pulses to go through coils on a specific region of the brain. So the pulses only go about 2 inches deep into the brain, making it easier to target those desired brain areas. Each pulse is brief, and it kind of shakes up those neurons and connections so that they can be rewired in a sense. And this rewiring can lead to multiple things, such as the stimulation of neurogenesis, modulating brain activity and neurotransmitters, and altering impaired cortical excitability. So pretty much most of the problems depression caused in the brain regions we discussed in terms of neuroplasticity can be alleviated with TMS, which is very promising. So thank you so much for listening to my presentation, and I look forward to reading your comments in the discussion board. Thank you.